Hello everyone. Today we are going to start our session with NC control system, that is the types of circuit. Okay, that means a NC machine which can be controlled through a circuit. There are two types of circuit, that is open loop and open closed loop. In open loop system, the signals are given to the motor, okay, by the processor, but the movements and final destination, okay, the movement and the final destination of the work table are not accurate, okay, and the open loop system cannot accurate, but it still can produce the shape that is required, okay. And in the closed loop system, it is equipped with a various transducer sensors and counters that measure the position of the work table accurately. In closed loop system, through feedback control system, okay, through feedback control system, the position of the work table is compared against the signal. Also, table movement terminate the table movement terminate when the power coordinates are reached, okay. Also, for the closed loop system, normally the servo motor uses, and for open loop system, the stepper motor is utilized. But if we compare these open loop and closed loop closed loop system, the closed loop system is more complicated and more expensive than the open loop system, okay. Now next we are going to see the coordinate systems, okay. So the distance or angles which specify the position of a point, line, circle, or any other geometrical figure with reference to a series of intersecting plane and cylinder defined coordinate system. These are two methods of listing the coordinates of points in NC systems, which can be used independently or in combination. So there are two types of coordinate system: absolute coordinate system and increment coordinate system. In absolute system, all reference are made to the origin of the coordinate system. All commands of motion are defined by the absolute coordinate refer to the origin, okay. That means, as you can see in figure, there are three holes are there. If we want to define the first hole, we can define it as a 30 30, which is from the origin. And if we want to define this second hole, then that we are supposed to define as a 70 60. And if we want to define this third hole, we can define it as a 110 and 90, okay. This is what we define in absolute coordinate system. Now in incremental coordinate system, this type of control system always uses as a reference to the preceding point in a sequence of points. Now here, let us see, if we want to define first point, then we can define as a 30 30. Now if we want to define the second point, at that time we are supposed to define as a 40 30, not 70 60, okay. And for third point, we can define this third hole as a 40 30, okay. Now in incremental coordinate system, the disadvantage of the system is that if an error occurs, it will be accumulated, okay. This is what the difference between absolute coordinate system and incremental coordinate system. Now next we will see the block diagram of a CNC machine, okay. This is the block diagram of the CNC machine. As we have already seen the information regarding CNC machine, still we'll see the brief information regarding this, okay. So the information stored in the computer can be read by a automatic means and converted into a electrical signal, okay, which operate the electrically controlled servo systems. Electrically controlled servo systems permits the slides of machine tool to be driven simultaneously and at the appropriate speeds and directions so that complex shapes can be cut, often with a single operation and without the need to reorient the workpiece. Okay, this is the block diagram of the CNC machine. Now, next we are going to see the DNC machine. Okay, that is a direct numerical control machine. Okay, so this direct numerical control can be defined as a type of manufacturing system in which several NC or CNC machines are controlled remotely from a host or mainframe computer, or direct numerical control, that is control of multiple machine tools by a single mainframe computer. Okay, so the basic DNC systems requires basic components are mainframe computer, memory, communication network, NC machine tool. The communication network can be done either through connecting the remotely located computer with lengthy cables to the individual machine control directly, or connecting the mainframe computer with a small computer at individual operators station known as satellite computer. The combination of DNC CNC makes possible to eliminate the use of program as the input media for CNC machine. The DNC computer downloads the program directly to the CNC computer memory. This reduces the amount of communication required between the central computer and each machine tool. Okay, as in the diagram you can see over here, different different NC machines are connected through a computer network to a host computer or mainframe computer. That means by using the only one host computer or mainframe computer, you can control various movements of the machines. Okay, now let us see the advantages of the DNC machine. So first advantage is that control of more than one NC machines. Okay, as you can see, by at one place you can control the many NC machines. Okay, and elimination of punched tape and tape reader. Okay, so elimination of punched tape and tape reader is there, where in this system there is no use of a punched tape and tape reader. And it is convenient storage of NC part program in computer files. Okay, so it is a very convenient to storage of NC part program in a computer file. And greater computational capability and flexibility, and the data for tools and cutters can be centrally maintained and updated. Okay, so whatever the data is there for the tools and cutters, that can be centrally maintained and updated. Hmm? And last one, that is inventory can be better controlled. Okay, these are the advantages, but along with that there are some disadvantages. Okay, so the major disadvantage of this system is that if the central computer, that is host computer or mainframe computer, goes down, okay, then all machines become inactive. Okay, if this host computer or mainframe computer stops to work, then all machines become inactive. And another disadvantage is that initial cost is too high. Okay, so this is what about the DNC machine. Now next we are going to see the machining center. So A computer controlled machine tool is capable of many types of cutting operations on multiple surface and directions on a workpiece without having to move the workpiece from one machine to another. Okay, that means without moving your workpiece from one machine, you can perform all operations at one place. Workpiece in machining center is placed on a pallet which can be moved in three principal directions, that is either x, y, z, and can be rotated about one or more axis on the pallet. Okay, they are capable of carrying out many operations, that is milling, drilling, rimming, tapping, boring, etc. And they do not need they do not need operator intervention for change of tools and workpiece. Okay, and these machining centers is these machining centers are equipped with a automatic tool changer. Okay, that we will see later on. A machining center is characterized by an indexable tool magazine which can store several tools, that we will see later on how it stores. Okay, and tools from tool magazine is transferred by tool changing arm to the machine spindle. Okay, so here that is horizontal machining center is there. It has a horizontal spindle. Okay, it has horizontal spindle. With a horizontal spindle, tool stick out the side of the tool holder and cut across the side of a workpiece. Horizontal machining centers are far more expensive than equivalent capacity of vertical machines, but have several advantages. Usually the tool holder of a horizontal machine is more rigid. Also, when machining the side of a part, metal chips fall out of the area being cut, leaving an uncluttered cutting area. This is what the horizontal spindle machining center. Now we'll see the vertical machining center. With a vertical spindle, tools stick straight down from the tool holder and often cut across the top of a part. One disadvantage of vertical machining is that when tool cut across the top of the part, the metal shaving called chips often pile up around the tool and interfere with the cutting action. Okay, this was the disadvantage of the vertical machining center. Let us see a few examples. This is the example of 5-axis CNC machine. This is the example of turret arrangement which is made on the lathe. Now next we are going to see the automatic pallet changer. Okay, so before that let us see what is pallet. So the workpiece is placed on a pallet, okay, which can be oriented in different directions by the machine. Automatic pallet changeover systems are used in modern CNC machines. These pallets simply move for interchanging their positions on the machine table. While machining is being done on a job kept on one pallet, the other pallets are accessible to the operator for clamping and unclamping raw material or finished product. This saves a lot of material handling and setup time, resulting in higher productivity. Okay, in this automatic pallet changer, in this system the pallet simply moves. Okay, that means suppose here if raw material is kept, and when this pallet moves over here, the different operation where performs over here. Okay, the different operations can be performed over here, but at the meantime here you can load again the raw material, and at the meantime here you can remove the finished product. Okay, from here it moves over here, again from here to here. Okay, so when the operations were performing over here, here the raw material is loaded, and the meanwhile the finished part can be unloaded from that side. Okay, here you can see on one of the pallet changer. Okay, so this is a typical pallet changer with a rotary style pallet changer. Okay, that means first of all you can see the workpiece is mounted on the pallet. Here the four pallets are there. Okay, so on one of the pallet the spindle is there, above the pallet spindle is there. That means first of all workpiece is loaded over here. Okay, again it moves and various operations were performed over here, and again it is unloaded. Okay, again here either it loaded over here or here, and after performing various operations the finished products can be removed from here. Okay, now let us see the further information regarding the automatic tool changer. Okay, so in a CNC machine, tools are changed through program instructions. The tools are fitted in a tool magazine or drum. When a tool needs to be changed, the drum rotates to an empty position, approaches the old tools, and pulls it. Then it again rotates to a position, the new tool fits it, and then retracts. The concept of the automatic tool changer is that the range of tools for a specific job shall be made available for automatic selection and positioning. The selected tool is transferred to the spindle from the magazine after the previous tool is transferred to the magazine from spindle. This is called a tool change cycle. Okay, I'm repeat once again. The selected tool is transferred to the spindle from the magazine after the previous tool is transferred to the magazine from the spindle. This is called as the tool change cycle. Automatic tool changer can switch up to 200 tools stored in a magazine, drum or change. Okay, so there are two types of automatic tool changer. First, that is drum type automatic tool changer. Here you can see various tools are there on the drums. Okay, so in drum type, for holding a small number of tools, usually not more than 30. Okay, that means up to 30 tools can be held on the drum. Okay, and these tools are stored on periphery of drum, and if you see the tools, okay, the tools are stored on the periphery of the drum, and as we know it has the capacity that only up to 30 tools it can hold. So due to that its search speed is faster. Okay, so this is what a drum type. Now let us see the second type, that is the chain type. Okay, in chain type automatic tool changer, for more number of tools, that is this chain holds more number of tools, that is either 4 or more than 40. Okay, and also its tool search is speed is less. Okay, here you can see the chain. Okay, on chain the tools holder is there, on that tools were mounted. Okay, now let us see the disadvantage sorry the advantages of the automatic tool changer. Lines changed line changes in seconds instead of hours. Okay, and also it increase operator safety by changing tools automatically. Okay, that means we have seen that in conventional machine it takes many hours or many minutes to change the tool. Okay, but here time required is less, and also there is operator safety for changing the tool. Okay, and change the tools in seconds for maintenance and repair, and it increases the flexibility. Okay, and heavy and large machine tools that are automatically exchanged. Okay, these are the advantages. Now further you can see over here the horizontal machining center with an automatic pallet changer. Okay, here you can see the chain type of automatic tool changer is there. Okay, and here the pallet is there. Okay, now further one concept is there, that is preset tools. That is the setting of tools in advance at a place away from the machine tools or offline in special holders is known as a preset tools. A presetting device is used to preset axial and radial position of the tool tip on the tool holder. Okay, once this is done, the tool holder is ready to be mounted on the machine and produce a known dimension. Presetting devices to various levels of sophistications are available. Okay, tool length and tool diameter compensation facilities available in present day. CNC machines have brought down the importance of presetting. Okay, as we know, the presetting was very important, but CNC machine that did this brought down the importance of presetting. Okay, so this was the previous. In olden days, this presetting was using. Okay, now let us see the further. Okay, that is the tools. Okay, so this is what the turning tool geometry. Okay, so if you observe on the tool, such designation will be there. Okay, T, this is the example that TNMG 220408. T is nothing but insert shape. Okay, the tool, okay, whatever the tool is there, that the shape of that insert shape, that is whether it is triangle shape, T triangle shape, S square shape, R round shape, or C diamond 80-degree shape, D diamond 55 degrees shape, or V diamond 35-degree shape. This is what the shape of the insert. And the second is N. N is nothing but the second designation is our insert clearance angles. Okay, that is if N is there, that means 0-degree clearance angle. B is there, if B is there, then the insert clearance angle is 5-degree, and if C is there, then it is nothing but there is a clearance angle of 7-degree. Okay, of the tool. Okay, and third word designate, it defines the tolerance. Okay, as you can see, so apart from M, there can be used a G or U. G is nothing but a tolerance of G is having a plus minus 0.001, and if M is there, then the tools tolerance is plus minus 0.002, and if U is there, then its tolerance is plus minus 0.005. And the fourth designation is a insert type. If A is there, then the insert type is a insert with hole is there, and if G is there, then the insert is have a clamp on with a chip breaker, and if M is there, it means insert is hole and the special features. Okay, and the fifth number, it shows the cutting edge length of that turning tool, and the second last number indicates the insert's thickness. Okay, and last number, it designates the nose radius of that insert or tool. Okay, that is, if 4 is there, it means 0.4 mm nose radius. If 0 it is there, 0.8 mm nose radius, and if 12 is there, it means the nose radius is 1.2 mm. If 16 is there, last digit, then that means the nose radius is 1.6 mm, and if 24 is there, its nose radius is 2.4 mm. So let us see the insert shape, clearance angle, and the insert type. Okay, in next slide. Okay, so here it is the first designation. We have seen the insert shape. So these are the shape of the insert, that is triangle shape, round shape, diamond shape, square shape. Okay, that is D, S, R, C, D, V, W. These are the shape of the insert. Okay, and the second one, that is the insert clearance angle. This we are showing the second digit, second word. Okay, that is insert clearance angle. We have seen that n was there, so here you can see the various insert clearance angle, that is B, that means the 5 degree, C 7 degree, E 20 degree, N 0 degree, P 11 degree. So these are the turning tools insert clearance angle, and these are all as per ISO 1832 coding system. Okay, and here the last one, you can see the turning insert type. Okay, that is with hole, clamp on with chip breaker, hole and specific feature. Okay, that is A with hole, this is with chip breaker, this is hole and with special feature. So these are the turning insert types. Okay, and this is the turning tool geometry as per ISO ISO 1832 coding system. Okay, here you can see the insert shape, insert clearance angle. They are total, if you observe, 7 alphanumeric codes are there. First 4 digit indicates the that is one by one. Let us see. First digit indicates the insert shape, second digit indicates the insert clearance angle, third digit indicates the tolerance, fourth digit indicates the insert type, fifth number indicates the cutting edge length, fifth sixth number indicates the insert thickness. Okay, that means whatever the cutting tool insert we are going to use, it shows its thickness, and last digit, it shows the nose radius of that turning tools geometry as per ISO 1832. Okay, and these are the various turning insert shapes, turning insert clearance angle, turning insert type. As per ISO 1832 coding system. Okay, these are the turning tool geometry as per ISO 1832 coding system. Here you can see the different shapes of that turning tools. Okay, turning tools, various shapes, turning tools clearance angle, and turning tools various types. Okay, that is the insert types. These are the shapes and those are the types. First is shape, and here the shapes are given over here, and the other types were given. Okay, so that's it. Today we are going to stop over here. Thank you.